quickly wanted to reiterate the trig identities. So these are properties that you have kind of already have seen prior in chapter 4, especially these reciprocal identities and the tangent and cotangent identities. As seen in the video a little bit earlier, that the tangent identities, they derive right from the unit circle and they're special right triangles. So I just wanted to just take a second to go over a couple other little things here about the identities. So I would say that it's a very good idea to either take a screenshot of these trig identities or print out this first slide so that you have them with you at all times, okay? Because you're going to have to reference these trig identities so many times. You don't need to memorize them, but the more that you use them and the quicker it is to use them, the easier this section is going to be for you, okay? So if we go on, there's just a couple little things I wanted to talk to you about these identities. So the reciprocal identities, there's some addendums to these rules. The reciprocal identities, you are able to change the 1 to any number. So I give you guys a couple of examples here. So if you look right up here, if I can put a 2 here, then I can change the 2 here. And that is good for any of these reciprocal identities. Okay, so you can see that I showed you an example here where I took the cosecant theta equals 1 over sine theta, which is the reciprocal identity. Remember, we talked about in the past that a reciprocal is basically that you put 1 over something. So cosecant and sine, we've already talked about them being reciprocals before, and this is why this works. Okay, before in the past when we would do a problem and you would say, oh, sine is equal to 3 over 5 in a triangle, cosecant, well, to find the reciprocal, you guys would have flipped it to do 5 over 3. Well, technically what you were actually doing was 1 over cosecant, okay, which meant that you were doing 1 over 5 over 3, and if I did the whole math out, it would come back to 3 over 5, okay? So if I have a 2 in front, if I put a 2 here, then that means that this now becomes 2 times 1 over sine, and that's why we end up with the 2 over sine, okay? So that's that. Then the next one is you could have a negative, like for example, a -1 times tangent, then would change this 1 over cotangent. I just have to make sure the negative's out front. Okay, so it doesn't always have to just be a 1, all right? That's that first part. Next, okay, is sometimes this goes for the reciprocal and the quotient identities. So that's going to talk about this entire section right here on the left-hand side. You can actually change the exponents. Okay, so that's really the only other thing you could do with this section, but it's really important that you know that you could do that. So you can see here that I have that this is a cubed and this is a cubed. So cosine theta equals 1 over secant theta. You could change it to cosine squared equals 1 over secant squared, or it could be cosine cubed over 1 over secant cubed. Okay, it doesn't matter as long as these exponents match each other. Okay, same thing with the quotient identities, tangent and cotangent. As long as if this is a squared, then the top and the bottom has to be squared as well. Okay, if you have cotangent, you can do the same thing. Cotangent squared is equal to cosine squared all over sine squared. And notice that these follow the same rules as with our unit circle. Okay, cotangent squared, remember, is the same thing as x over y. Okay, and remember that cosine is the x value, and they follow suit. Okay, so they all go together. All right, so those are those two rules. Moving on to the next one, the Pythagorean identity rules. You will use these a ton, okay? So that's why I want you to really pay attention to these 3 rules right here, okay? I have them written out in this form, but you can rewrite these in any way. And basically what I mean by that is that you can add or subtract them across the equal sign however many times you need to, and they will still be equal. They'll be equivalent to each other, okay? So I show you a couple of examples here, okay? So like sine squared plus cosine squared equals 1. If I take this entire cosine squared and subtract it over, then it becomes 1 minus cosine squared. So sine squared can be the same thing as 1 minus cosine squared. Okay, and you can rewrite these any way you want to as long as you just add and subtract them over the equal sign. Then I showed you this one. The main identity is 1 plus tan squared equals secant squared. Well, what if I decided to subtract tan squared over? Okay, so I subtracted tan squared, all right, and I got this identity, all right, is equal to 1. Well, then I decided to take it one step further. I said, okay, well, what if I decided to take secant squared and subtract that over? Okay, if I subtract secant squared over, now I'm left with negative tan squared equals 1 minus secant squared. All three of these identities are all equivalent. They're just all in different forms. Okay, they're all exactly the same. Okay, there's so many different ways that you could write this. Okay, technically I could, you know, do it. I could have tan by itself. If I just wanted tan squared by itself, you could do that. Okay, I missed number 1 here. Just always know that for the Pythagorean identities, they must always be squared. Okay, so like I put right here that this is not equal. Okay, this is a no-go. They have to be squared, the sine and the cosine, for all the trig identities in that Pythagorean category. And then last but not least, you can multiply the entire expression by a negative. So for example, if I have sine squared plus cosine squared equals 1 and I need them to be negative, I can take this entire expression and multiply it all by a negative as long as it goes distributed to every single piece, even across the equal sign. Okay. And then last but not least is our even and odd identities. Okay, so even and odd identities, there's a bunch of them. Okay, there's 6 of them because we have 6 trig identities. And I just wanted to point out to you that if you notice that cosine and secant are different than the other 4. Okay, and there is a reason for that. Cosine and secant are the only ones that are even. Okay, so which means that they're symmetric to the y-axis. So when I flip them, they become a positive function. Okay, as you can see right here, they're positive versus the other 4 odd functions. So when they're symmetric to the origin. So they have a negative when I take this identity. Okay, and the only time you are ever going to use these is when you are given a negative angle. Okay, if you do not have a negative angle, then you're not using these even odd formulas ever. Okay, and I think that wraps this up for trig identities. Okay, basically when we really get into the nitty gritty of this is to just realize that this is going to take some time to learn. You're just going to have to try things. There's multiple ways to do what we're going to be doing, which is simplifying different trig expressions. And we'll take it step by step. And I promise you that even though we start off with a little bit of confusion in the beginning, you will get it by the end. Okay? All right, make sure you print out this trig identity sheet and get it close to you because you'll be using it a ton. All right?